Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at the shape of the exponential function. Now, if you guys can recall, in the previous video, I introduced you all to the standard form of the exponential function, which had the equation y is equal to b to the power x, where b was your base, and the x values along the x-axis would now be the exponent that b is raised to. In order to understand the shape of the exponential function, I am going to introduce a new variable into this equation, and this will be the variable a. So the equation is now going to be y is equal to a times b to the power x, where b is still the base of x, and we are multiplying a by b to the power x. Now I'm going to try to explain to you guys the functions of these variables and its characteristics, which is extremely important. Let's look at the variable a first. Now when it comes to the variable a, this is going to give us the value of our y-intercept. Now this is important, and you guys will understand this a bit better as we progress in this video. A is going to give us the value of our y-intercept, and a can be any number. It can be negative, it can be positive, it does not matter. A can be any number because that is the characteristic of a. When it comes to b, when it comes to the value of b, b can be any number that is greater than 1 or b can be any number that is less than 1 but greater than 0. And this is important. When I'm speaking about b being less than 1 and greater than 0, I'm telling you guys that b is a fraction. It can be a half, it can be a third, it can be 1/100th. It does not matter, it is a fraction. But b will never ever be negative, and that is extremely important. If you have a negative value in your equation, that negative sign will be assigned to a and not to b. Okay? Now there are 4 types of shapes that you will get for your exponential function. The first type will be the type of function that we did in the first video, and it would look something like this. Now let's look at the characteristics of this function. We know that x is our asymptote, and as you can clearly see, this function lies above our asymptote. The next thing I want you guys to take note of is the fact that this function is increasing. When I speak about the function increasing, I am speaking about its gradient. And to determine whether a function is increasing or decreasing, we look at it from left to right. If its values are increasing from left to right in terms of x values, it would be an increasing function. If its values were decreasing from left to right, it would be a negative gradient and a decreasing function. Now the only time that this function will take the shape is when a is positive. So a must be greater than 0. I'm just going to put a little plus sign over there. And b will be greater than 1. This is important. That means that b can be 2, b can be 3, b can be 4. It's fine, it doesn't matter. B can even be 4/2. B can be 3/2. It's a fraction, I know, but it's still greater than 1. That's an important characteristic. So when we have an a value that is positive, and when we have a b value that is greater than 1, we will have a function that lies above the asymptote, and it would be increasing. Now if I were to tell you that a is now less than 0, meaning a is negative, and b is still greater than 1, the function would look like this. we would obtain a function that lies below the horizontal asymptote, below the x-axis in this case, and it would be a decreasing function, meaning it would start off with y values that are high from the left hand side, and as you progress towards the right hand side, the y values would get lower and lower. The next case would be where a is greater than 0, meaning a is positive again, and in this case b would be less than 1 but greater than 0, meaning b is now a fraction. In this case, we would have a function that is above our asymptote, but it would be decreasing in nature, meaning even though our function is going to be above the x-axis, above the asymptote, if we look at it from left to right, the y values would get smaller and smaller as the function progresses. When a is less than 0, when a is less than 0, meaning it is negative, and b is less than 1 but greater than 0, we would get a function that lies below the x-axis, below the asymptote, but this function would now be increasing. That would mean that the function would take a shape that looks like this. The function would start off with low y values, and as it progresses towards the right, its y values would increase. So that's just what it is in a nutshell. That's how we would look at shape for the exponential function. A rule of thumb in order to make this a bit easier: when a is greater than 0, the function would lie above the asymptote, so it would lie in this region here. Okay? When a is less than 0, when a is negative, the function would lie beneath the asymptote. It would lie beneath the x-axis. That's how the value of a would affect the function shape. Okay? If we have a value of b that is greater than 1, meaning b is going to be a whole number, it could be a complex fraction, we would end up with a function that looks either like this or like this. It would start off close to the x-axis and it would progress upwards in its direction. In this case, it would start off close to the x-axis and it would progress downwards in its direction. Understand? But if b is less than 1 but greater than 0, it would start off away from the x-axis and would progress towards the x-axis in its direction, as you can see in this case over here, and in this case towards the right, you would see that it would start off away from the x-axis and it would progress towards the asymptote or towards the x-axis. That's just a simpler way in order to understand it. Remember guys, this is theory, you have to learn it. If you do not learn it, you're not going to understand the section well. You're not going to be able to apply yourself well. So please, whatever you do, make sure you know this. That's it for me guys. All the best, and I will see you in the next one.